welcome to the rules. This is video notes 13, and these are the rules of derivatives continued. And we're talking about the product and quotient rules. You can probably guess in what situations you would use them. It's when you multiply two functions together, or you divide two functions. And we have a specific way of remembering this monstrosity down here. But for the product rule, we are going to have a combination of functions that involves the derivative of one multiplied by the original function of the other, and then adding the original function of the one and the derivative of the other together. So it's like you're mixing and matching the derivative and original function of each function together and just adding them. So in some cases we might not even need to use this rule, because if we look at this, that's just two binomials. So we could do this without the product rule by rewriting it, which we've kind of discussed before. And if I multiply this out, then we can get there pretty easily. Plus 20x. It should be squared. There we go. So if we take the derivative of this now, we don't even have to use the product rule. 18x squared. Let's see. This is minus 24x and minus 20x and plus 20. So the end result, if we can combine like terms, which is a pretty easy thing to do when it comes to simplifying, then we get this as our answer. Now with the product rule, I'm going to use some different colors here just to differentiate what I'm doing. So whenever you see the pink function, it'll be referencing the pink math, it'll be referencing that 2x squared minus 4x. So I need to write the original function. So we're just jumping straight into the derivative, not even simplifying anything. And then I need to write the derivative of the green function. So I've got 3 plus the derivative, or we can write it how it is noted in here, but I could just do the derivative of the pink function first. I'll just go ahead and write the derivative of the pink function first, because that's our first function. So I'm going to do 4x minus 4, and then times the original green function, 3x minus 5. So this is the derivative. This does mean y prime. When we use the product rule, we immediately start finding the derivative. Whereas in this case, we had to rewrite and not use the product rule. But the simplifying process is just a little bit more effort on the other end of the product rule. And that's just distributing this 3. And then multiplying out this binomial. So on. Y'all have multiplied out a binomial before. And so we got to do plus 12x squared minus 12x minus 20x plus 20. And it looks like we should end up with the same answer if we can add this correctly and combine like terms. So there's those. Then we've got minus 44x with all these plus 20. Yay! Now with B, I have altered the notes a little bit, so the function has some a little bit more challenging values. The way we're going to do this, you could multiply them together, but instead we're going to use the product rule just to prove that we can do it. And I do need to rewrite this before I even start the product rule, because I have such strange exponents on a couple of these terms. So nothing strange about those, but then here we go, we have x to the negative 1, because that's what 1 over x is, with the negative exponent, times x to the 1/3 plus 2. Alright, so now we're ready to use the product rule. And I'm going to set this up so you can see it, and I'll simplify quickly after that. So setting this up is going to go like this. We've got the original function x squared minus 1 minus x to the negative 1 times the derivative of this pink function. So let me denote those real quick, which is going to be 1/3 x to the negative 2/3, because I subtract 1 from 1/3. There we go, and then we'll add. And just to show that we can do it in a different order, because remember, multiplication and addition are commutative, which means you can do them in any order. I'm just going to write x to the 1/3 plus 2, and now the derivative of the green function. Which, if we look at x squared, that's just 2x. If we look at negative 1, that's 0. And then when we look at this number right here, or this number, we've got negative 1 times negative 1. And that's 1, so plus 1, because it's a positive 1. And then x minus 2. And I subtract 1 from negative 1. Great. So this is the derivative. This is f prime of x. So we have found an answer. Simplifying is going to be a little bit of a trick, because when we multiply and distribute this 1/3 x to the negative 2/3 out to the rest of these functions, then we're going to add the exponents and multiply the coefficients. So I'm going to do that real quick and see if you get what I do. So there we go. We have the simplified form of this monster. We really can't combine any other like terms besides what I've underlined in red. The degrees have to match in order to combine like terms. So you can't add terms together unless they match in degree. So that's it for that one. Part of what this is an extension of is just simplifying. Is going to be a little bit of the score here if I'm asking for like a score out of 5. And this is obviously one of the most difficult problems you could see. So I wouldn't be too scared of this. 90% of the points is going to be held within just using the product rule. Now, I'd like you to try letter C here, and then we'll come back and we'll talk about the quotient rule. Oh my goodness, what a beast of a problem, especially when it comes to simplifying. The derivative part wasn't so bad, but simplifying, you just have to multiply a lot of terms out. So this is what I got when I multiplied everything out. It didn't even fit on the page. So if you're trying to fit this, I mean, I've got a pen here, so I can be pretty flexible, but yeah, there's a lot of organization that you would need to do this one. So hopefully you were able to find the same answer I did, which is right there. Now, like I said, the simplifying process, I'll only ask you to simplify, and it'll be clear in the directions on the practice, because the practice is down here. If it'll load in. There it goes. Do your best to simplify. So for the practice, I'm asking that you would try to simplify. On the quiz or test, I'm going to say, simplify this, don't simplify this. The quotient rule, however, is a little bit tricky. It's got a strange pattern to why it fits like this. And we don't derive, so we don't like see where this quotient comes from. But we could, and maybe I can direct you all in class to some videos on the derivation of something like this. So where does it even come from? Why do we have this combination of derivatives and original functions that means the derivative of two functions divided? And so I can post another video like that from another source, but right now we're just focused on using it. So the way to remember the difference quotient, because if you don't have it written at the top of your page like this is, then it's pretty tricky. You've got to remember low derivative high minus high derivative low, and that's all over low. If I could draw a division bar, it's all over low. So that's low d high minus high d low over low. And you can say that out loud and see how silly it sounds, but it's a great way to remember the quotient rule. So if this is low, the lower function, and this is high, then you've got low derivative of high minus high derivative of low over low. So that's where that little mnemonic comes from. Alright, so we're going to use the difference quotient to determine these functions' values, or these derivatives. I shouldn't say function values. So for our derivative, there's nothing we can do to rewrite this one. It would be great if we could, but there's just not. The only way we can take the derivative of this is by the quotient rule. So we've got high and low, and you can mark that if you like, just so you can remember to use it. You got low derivative of high, which is 0, minus high derivative of low, which is 3, over low. So 3x minus 2 squared. Yay! Notice I used parentheses when I have a binomial in my division. So at this point, you've taken the derivative. That's like most of the points. Simplifying again is the trick. So y prime is going to be, this one's not so bad to simplify, negative 15, because that's 0, the left side's 0, over 3x minus 2 squared. And notice too, I didn't multiply out 3x minus 2 because it's actually a little bit more confusing as to what the denominator actually is if we multiplied it out. We could even tell when the denominator could be 0, and that could be 0 when x equals 2/3. So we actually don't want the denominator equaling 2/3 because then this would be undefined. But for example, that's why we might need to keep the denominator like that. So if you can get to this point, the simplified version, then that's fantastic. I have B and C to show you, and then I'd like you all to try D after that, and then I'll show you the answer to E, and maybe we can discuss that in class as well, because I'm running a little bit long on time. So let's just talk about B and C, and then I'll just show you the answers to D and E there. On B, we're just practicing low D high minus high D low. So we've got low D high minus high, using parentheses, D low, all over low. So I get 2x plus 1 squared. Don't multiply it out. So that means, oh, I'm getting a phone call. So that means we can simplify this now that we have our derivative. So I'll just distribute that 4, 8x plus 4 minus, keeping my parentheses because that minus could really mess us up when we simplify, minus 8x minus 6 all over 2x plus 1 squared. Don't multiply that out. So I'm going to end up with 8x minus 8x. Get rid of these parentheses. I'll just distribute that negative then. plus. And so that's just 10 on the numerator. Yay! So that's it. That one's not so bad to simplify. Now C, there's just one more term in the denominator. I'm going to use a different color. So y prime is going to look like this. Low d high, so -1, minus high, -x. Notice I use parentheses still, because I'm subtracting. Minus high d low, so we've got 2x plus 4 over x squared plus 4x minus 2 squared. Now, we've been using the power rule all throughout this process, so we can use different derivative rules inside of others. And that's kind of where we can extend some instruction here, but for right now we're just focused on using these rules. Power, product, quotient, and of course the constant multiple rules. So simplifying this, we just distribute that -1, and then we can, I'm going to keep my minus and I'll distribute this -x because it's a little confusing. So -2x squared minus 4x. Now I'm just going to distribute that negative, so that's a plus, that's a plus. So that's my numerator. That can be simplified. I'll just write my denominator real quick. And now I can combine like terms in my numerator. So I've got an x squared plus 0 plus 2. Because these guys cancel. Bye bye. That's all over x squared plus 4x. Oops, come on, Ben. Wake back up. There it goes. Minus 2 squared. Alright, so overall, I'd say that this wasn't as bad to simplify maybe a more complicated problem than the product rule. Product rule is kind of a beast. Okay, so I'm going to leave this here, and if you all want to check your answers to D and E, then right after I end here, they'll just pop up on the screen for a little bit. Thanks, have a good one. Holy cow, the quotient rule is a lot more work in some cases, and that's what this last part was trying to prove. So the power rule, if you can rewrite, is the much easier way to go. There you go, versus 3 lines. If we compare these two, if you can rewrite the original function in just 2 steps, so there's 1, there's 2 steps of rewriting, it's super easy. I'm sorry, there's 3 steps of rewriting. 1, 2, 3, those yellow arrows, it's 3 steps of rewriting. But it is a little bit easier algebraically to rewrite and then take the derivative. Otherwise, you take the derivative in 1 step, and then you have 1, 2, 3 steps to simplify that. I think this one is way easier. Alright, bye.